Good morning, my dear judges. Uh, uh, Today, my international conference paper ID is 895, and my title is Hybrid Deep Learning and Generative Augmentation Framework for Robust Multimetric Lung Cancer Detection, a comparative evaluation of CNN, RNN, and lightweight architectures. We have integrated convolutional neural networks and recurrent neural networks for lung cancer detection. By using these techniques, we are leveraging and integrating with the hybrid model. And this is Asadi Srinivasulu, and my colleagues are Shivashankar, Vijay Bhaskar, Ramohan Reddy, and Pradeep, Varshita, and Godinla Srinivasulu. A warm welcome to International Conference on Artificial Intelligence and Networking, that is ICAIN. It is a Springer conference on 6th, 7th, and October 2025. And today's my agenda is abstract, introduction, literature review, research gaps, proposed methodology, data sets and experimental setup, results and discussion, comparative analysis, conclusion, and future work and references. We have collected nearly 5,000 chest and CT scan images from free repositories like Kaggle, GitHub, UCI repositories. And coming to abstract, in my research, we have developed a framework called GenX LungNet, a hybrid deep learning framework that integrates convolutional neural networks and recurrent neural networks, and we are integrating with the generative adversarial networks based augmentation to enhance lung cancer detection from CT, computer tomography, and X-ray images we have collected from the various free repositories. The proposed system, we have applied a GenX LungNet with integration of various frameworks, achieved superior performance with the CNN plus RNN with the various frameworks, hybrid model reaching 96.4% accuracy and 0.95 FN score and 0.97 AUC, outperforming traditional and lightweighting models. These findings highlight the potential of combining hybrid architectures, generative augmentation, and explainable AI tools for scalable, accurate, and interpretable diagnostic applications. And in this, lung cancer is leading cause of cancer-related deaths worldwide, where conventional diagnostic practices often face challenges like cost, delay, and human error. For that's why we are choosing latest hybrid framework, and it highlights the need for robust and scalable. If you increase the size of the data, also it can support and interpretable artificial intelligence systems, integrating various techniques like convolutional neural networks, recurrent neural networks, and generative adversarial networks, and lightweight models like MobileNet V2 and segmentation net to address gaps in existing research. So the proposed framework GenX LungNet framework introduces a novel hybrid approach with generative augmentation and explainability tools, aiming for accurate, efficient, and clinically applicable lung cancer detection across CT and X-ray modalities. We have collected nearly 20 literature survey papers for developing this paper, and we have segregated columns like author name and followed by the limitation and issue challenges and existing method and proposed method, what they have applied on these 20 papers, what type of data sets they have utilized, and what are the techniques they have applied and tools they have applied, validation metrics, future detection, future directions, and followed by the references. So we got research gaps from this literature review. Then we have proposed hybrid models, and these are the research gaps we have identified: lack of unified benchmarking across architectures, limited exploration of generative adversarial network hybrid models, and underutilization of lightweight architectures, limited explainability and interpretability tools. And this is the proposed methodology we have applied. that is GenX LungNet, and we have given as input data sets like chest X-ray images, CT scan chest X-ray images, and 80% of training and 20% of testing we have applied, and we have integrated with the CNN, RNN, and various hybrid models for classification. In RNN, we are using LSTM for ordered two-dimensional frames, the combination of MobileNet V2 and deep learning and MobileNet V2. We got very good accuracy for this proposed model. The research introduces various integration frameworks like CNN, RNN, and GAN based augmentation to enhance lung cancer detection from CT and X-ray images through multimetric evaluation and explainable AI. And finally, the results CNN plus RNN hybrid model achieved the best results with 96.4 accuracy, and we have validation metrics like FN score 0.97 and 0.95 is FN score, 0.97 is AUC. It is outperforming comparatively existing models, and these metrics shows the outperforming. GAN, generative adversarial network augmentation, improved recall and FN score by generating realistic synthetic samples, helping to reduce overfitting and class imbalance research gaps. Lightweight models like MobileNet V2 and Segmentation Net showed a slightly lower accuracy but demonstrated strong potential for real-time and resource-limited deployment, while explainability tools enhanced clinical trust. So this is the model accuracy comparison of for proposed framework for robust multimetric lung cancer detection. In x-axis we have taken various models like CNN, convolutional neural network, recurrent neural network, CNN plus RNN, GAN based augmentation, MobileNet V2, and segmentation model. And accuracy we got combination 96.4, that is outperforming comparatively existing models. So the finally we have developed a comparative paper with validation metrics like accuracy, final training loss, validation loss, time complexity, epochs, interpretability, and convergence speed, overfitting risk, robustness, generalization. Finally, our proposed model got accuracy 96.4 percentage. Comparatively existing system, we have run our program up to 50 epochs by using Google Colab with Python programming, and successfully we have completed on various chest and CT scan images, and we got a very validation loss is 0.07 and final training loss for 0.09 percentage. So our research demonstrates that a hybrid model called GenX LungNet integrating CNN, convolutional neural network, recurrent neural network, and GAN, generative adversarial networks for augmentation, we have achieved a high accuracy 96.4 percentage and strong generalization across CT and X-ray data sets. The framework not only improves recall and FN score for underrepresented cancer cases but also supports clinical trust through explainability tools. Future work will focus on federated learning, multimodal integration, and advanced generative adversarial networks and extended clinical validation to enhance scalability and real world deployment. So these are the 20 references we have collected, and we have successfully completed a literature survey table, and we got research gaps. Finally, we have proposed our proposed model, and finally we have achieved 96.4 percentage accuracy. And thank you for giving me this opportunity for exploring on lung cancer detection. And thanks for supporting my co-authors Shivashankar, Vijay Bhaskar, Ramohan Reddy, Pradeep, and Varshita, and Godinla Srinivasulu for their contribution for performing this paper. On each contribution is valuable for this paper. And any doubts if you are having, please raise in this occasion. I would like to clarify your doubts.